So in this video, we're going to be solving triangles, SSA triangles. This is the case 2. So this applies to triangles for which two sides and the angle opposite one of them are known. This is sometimes referred to as the ambiguous case. Why is it the ambiguous case? Because the known information may result, it could result in one triangle, could result in two different triangles, and it could result in no triangle at all. Okay, so suppose that you had sides A and B and some angle that are given. So you had this angle A that's given, and then you know side B and side A. Okay, now if A is not long enough, then you can't even form a triangle with this information. Okay, so with what's given here. So the key to determining how many triangles, if any, may be formed from the given information lies primarily with the relative size of A. If A is too small, then you can't form that triangle. So how do we do the relative size of A with respect to that height? We use the fact that the sine, okay, the sine of capital A, well, the sine is opposite over hypotenuse, right? So the sine of A, okay, equal to opposite over hypotenuse, okay? So that's that H. And so to solve for that H, we get H equals B times the sine of A. Okay? So here's the deal. If A is less than H, okay, so it's shorter like it is in this picture here. So if A is less than H, which is equal to B times the sine of capital A, then what? Then side A is not sufficiently long enough to form a triangle. Therefore, there's no triangle, okay? However, if the side A is equal to H, which is B times the sine of capital A, what does that mean in the picture? So if this is H here, and the sine of A, and that's A there, if these are equal to each other, then they're the same, okay? And what does that tell me? That tells me that side A is exactly long enough. It's just long enough to form a right triangle. Okay? It's exactly long enough. Now, if triangle A, if A is greater than or equal to oh, here, let me do this. Let me do this other one first. Okay, so this one here, so two triangle scenario. This would be if H is equal to B times the sine of A, which is less than A, and A is less than B. Okay, so what does this picture look like? So this is angle A, this is B here, and it's longer than this A here. Then you can make two separate triangles. Okay, so how does that happen? Well, you could have this scenario, right? Capital A here, little a, and then little b there. That's one of them. And then the other scenario is like this, little a and b and capital A here. Okay? So those are the two triangles that you could do. Now this works because B is longer than A. So you got to have this and this. Okay, that and there. Then two distinct triangles can be formed from the given information. Okay. Now, if H is equal to B times the sine of capital A, and this is less than A, along with A greater than or equal to B, then only one triangle is formed, and that triangle looks like this here. So your little a is bigger than or equal to that b there. Okay, and so that would be the case where a is greater than or equal to b. There's only one triangle that can happen here. Okay, this scenario, we've got b sine of capital A is less than little a, and little a is less than b. Okay, so those are my three different scenarios with the SSA, the ambiguous case. So it's ambiguous because we don't know if there's one triangle, two triangles, or no triangles at all until we start checking. Okay, so it all hinges on this factor here. All right, so if I draw this out, so I've got my B and my angle A. Okay, if my A is short, okay, then no matter what I do, no matter how I rotate it, it's always going to not complete that triangle. Now, if it's longer, it's exactly that length. It'll take one right triangle. If it's a little longer, but still it's less than the B over here, you could have a triangle here. You could have a triangle here too with that same length. But as soon as I get an A that's actually bigger than the B, well, there's no way to make the triangle on this side, not with that angle A, but you could make the triangle come out over here and be an obtuse triangle. Okay, and that's where we have the one case. So basically what's happening here is we've got a couple of cases. We got the first one where the A is too small to make a triangle. Then all of a sudden the A gets big enough to make a right triangle, perfect right triangle. And then if A gets any bigger, but it's still not bigger than the B, then you can make a triangle over here and a triangle over here for the two case. But if A gets bigger than that long side B, then there's only the one triangle that can be formed. Okay, so hopefully that helps you understand what's going on there with the different cases. Okay, so let's work some examples to illustrate these cases. So let's use law of sines to solve an SSA triangle where there's no solution. Okay, where there's no solution. So say we know that little a equals 2, little c equals 1, and capital C equals 50 degrees. So if I draw a picture, might look something like this, 50 degrees for my angle C. So angle C is opposite this side 1, and then this A here, this little a, is 2. That's little c. So it looks like we're not going to be able to form a triangle and have this angle of 50 degrees here. Okay, but how do we verify this? Well, when I do this, I can use law of sines. Sine of capital A over little a equals sine of capital C over little c. And so that would be the sine of A over little a equals the sine of 50 degrees, that's my C, over little c, that's 1. And so that tells me that the sine of A is equal to 2 times the sine of 50 degrees. Now if I type that in my calculator, 2 times the sine of 50, I get 1.53. 1.53. Well, I've got a problem here. The sine of something cannot be greater than or equal to 1. Okay, so it's the biggest it can be is 1. The sine of A, remember, is stuck between 1 and -1. So it's impossible. It's impossible to get 1.3. So since there's no angle A for which sine of A is greater than 1, okay, there can be no triangle with the given measurement. Okay, so no matter what side the C is positioned to, it will never touch this B side over here. Okay, so no solution. All right, for the next one, we're going to do A equal to 3, B equal to 2, and capital A equal to 40 degrees. Okay, this is going to be where we have one solution. All right, so SSA, one solution. Now, with this one, this picture here, so I've got a triangle, and so I've got A equal to 3, so that's a capital A over here, which is 40 degrees. Yeah, okay, that's fine. And then B, yeah, I messed up. I want this to reflect the size. So this A equal to 3, that's look, my picture, I've got it, it's a little bit bigger. So this would be equal to 2. So capital A would be 40 degrees here. This would give me angle side, okay? So that's that SSA going on. Now, if this is a little c, that's capital C, and then this is capital B over here. Okay? So let's see if we can't solve this triangle here. The sine of A over little a equals the sine of B over little b. So what is this going to be? This is the sine of 40 degrees divided by 3 equals the sine of capital B divided by, well, what is B? B is 2. So I'm going to multiply both sides by 2. And so I get sine of B is roughly equal to 0.43. Now, there are two angles that I can do here for which the sine of B is equal to 0.43. Okay. And so if I do the sine inverse of 0.43, I get 0.254. 254. Uh-oh. So angle B is 254. And what else do I know? Well, it could also be let's see here. It could also be 180 degrees minus 0.254, which is 154.6 degrees. Okay. The second possibility, this 154.6, is ruled out because A, we know, is 40 degrees. And so 40 degrees plus 154.6 is greater than 180 degrees, which is in a triangle. Okay? So that's not going to work for us. So this one is not even a possibility. So this here is my answer. So if I know that this angle is 25.4 degrees and this one's 40, I do 40 degrees plus 25.4 degrees plus C equals 180. So that means C, if I subtract those out, I get 114.6 degrees. Okay? Now, the third side, by the law of sines, I get sine capital A over little a equals sine capital C over little c. Since I have my angle, I can plug it in. So little a, so sine of 40 degrees over little a is 3 equals the sine of 114.6 degrees divided by c. If I solve this for c, I get c is 3 times the sine of 114.6 divided by the sine of 40. And when I type that in my calculator, 3 times the sine of 114.6 divided by the sine of 40, and I get 4.24. All right, 4.24 is this last side here, 4.24. So now we have solved the oblique triangle because we found all the sides and all of the angles. Okay. So let's do the last case where we might have two possible solutions. So SSA triangle with two solutions. So we did one with no solutions, one with one solution. Now we're doing it with two solutions. So A equals 6, B equals 8, and capital A equals 35 degrees. So side angle, right? So when I draw my picture, got 35 degrees here, and this is side B, and side 6 can either be here or it can be here. So this is 6 or 6 here. Okay, so there's two triangles, two possible triangles. Why? Since A is less than B, okay, so since A is less than B, you've got these two options here. Okay, you've got this option here and that option there. All right. Now, law of sines, sine capital A over little a equals sine capital B over little b. Okay. So, when I run through this, I get the sine of 35 degrees over 6 equals the sine of capital B over, well, what is it going to be? The sine of capital B over little b is 8, multiplied through. So I get the sine of B is equal to what? It's equal to, I guess 4 over 3 if those simplify, sine of 35 degrees. Type that in my calculator. I get 0.76. Now the sine of B hits 0.76 in two places. So that first place, if I do sine inverse of 0.76, what do I get? Sine inverse 0.76, 0.4946. So I'm going to say 499. Okay, so just so let's say 49.9 degrees. All right, if you did this exactly in your calculator, you'd have to do the sine inverse of, I guess it would be 4 divided by 3 times the sine of 35, close parentheses. And that's where that 499 comes from. Okay, so that's a rounding error going on our part. Now, that is one of the angles, but to get the other angle, I'm gonna take the supplement of that, and so that means I subtract from 180. So theta, so that B equals 49.9 degrees, or that B equals 180 minus 49.9 degrees, which is equal to 130.1 degrees. Okay? Now, check to see if both of them are viable options. Well, if I add the 35 degrees plus the 49.9 degrees, that's certainly less than 180, so that's okay. And if I add the 35 plus the 130.1 degrees, that's still less than 180, so that's okay too. So both of those are going to produce triangles. The first one's going to produce a triangle like this. And the second one produces a triangle like that. Side 6, side 8, side 8, side 6. 35 degrees, 35 degrees. Okay. Actually, I've swapped these around in the wrong place. This one is actually going here, and this one, that one goes there. Okay, this is my angle B. That's my angle B. So that's the two pictures there. Okay. So we've got two results. So that tells me for that triangle, my angle C is going to be what? It's going to be 180 minus 35 minus 49.9, which roughly gets me 95.1 degrees. And this triangle's angle C gets me 180 minus 35 minus 130.1, which gets me 14.9 degrees. Okay? So if I'm going to work through with this triangle to get the side C, I need the sine of A over little a equals the sine of C over little c. So that's the sine of 35 over 6 equals the sine of, well, we got 95.1 over little c. And if I solve for little c, I get 6 sine 95.1 over sine 35, which is roughly 10.42. And for this triangle, sine of A over little a equals the sine of C over little c. Gets me the sine of 35 over 6 equals the sine of 14.9 over little c. So C is 6 sine 14.9 over sine 35, which if I type in my calculator, I get 2.69. Okay, so those are the two different triangles that are formed. So we have, so just to summarize it, you got side 8, side 6, and then 10.42. And so that's a 35 degree angle. You've also got that 14.9 degree angle, and what was the other one? 49.9 degree. Okay, and then your other triangle was 2.69 and 8 and 6, and that's 35 degrees. This was the 130.1, and then this one over here, this was actually the 14.9, and so this, so I messed this part up here. Let me erase that. Uh-oh. All right, so this angle up here is 95.1 degrees. This angle down here was the 49.9. Okay? So those are the two cases. So, or two triangles. Okay? All right.